Friends, yes, good evening everyone, and let's start today with a new topic which is related to your optics. And in your optics, the topic which I am going to cover today is Fermat's principle, which is important for your IAS physics optional purpose. As far as already said to you that in the channel Advanced Physics, Advanced Physics channel, you can watch this Fermat's principle and all on the Advanced Physics channel, but over there it is not from the examination perspective. I am teaching over here in the examination perspective. So he has taught for the BSc students, I am teaching for IAS physics optional perspective. A little bit difference is there, not much difference. So these are the things. So let's start. And you already know that my laptop new system update is there in the Windows, but that system update is not working actually. It is showing some error, so it is not. I am not getting that. So let's start. Fermat's principle. Just a second. The handwriting might be a little bit bad today because I am making this on tablet. I am not making this on laptop. So that's why. So Fermat's principle, it is a mathematical tool. What is it? It is a mathematical tool to deal with behavior of light in geometrical optics. It is basically a mathematical tool to deal with the behavior of light in geometrical optics. It was brought in even before Newton put forward the theories of light. Even before Newton put forward the theories of light, even before that this theory existed. So the original statement was different. Original statement of this principle proved to be a wrong one, and later a modified statement was brought in. So the Fermat principle states, now the modified statement, which is the modern day statement, which is well accepted statement. The well accepted statement is that the actual path described, the actual path described by a ray of light in moving from one point to another by way of a number of reflections or refractions is such that it always corresponds to the one for which the time taken is an extremum compared to the other nearby paths. That is, it is either a maximum or a minimum or stationary. With respect to variations of the path. Okay. Just a second, guys. What is this? I don't know. But okay. I don't know even new page can be taken in this or not. Okay, I am not able to see whether new page can be taken in this or not. Okay, I am not able to see. Okay, this is a new this thing for me, new altogether a new tab for me. Okay, so the actual path described by a ray of light in moving from one point to another by way of a number of reflections or refractions is such that it always corresponds to the one for which the time taken is an extremum compared to the nearby paths. That is, it is either a maximum or a minimum or stationary with respect to variations of the path. Let us understand the meaning of this statement. Okay, let us understand the meaning of this statement. Suppose I have a point over here, and suppose there is another point over here which is a point B. Okay, and suppose this is another path. Suppose this is point number D, this is your point C. Okay, and the light is, this is your DS, which is the elementary distance, and this is your point P having coordinates X, Y, Z. Okay, and the differential element ds is over here at the point P, and ds is so small that it is exactly equal to a point. Okay, so it is equal to the point P. Now the thing is that the distance this light will travel in going from A to B. Okay, light will go from A to B, right? So it can either go through C or either through D, depending on how the medium is there. How are the refractive indices at various points. Okay, how are the refractive indices at various points, depending on that. So how are the refractive indices on these various points. Okay, on these various points, depending on that your this thing may be there. What your these paths may vary. Okay, these paths may vary depending on what are the refractive indices at these various points. Okay, so that's what is this. But for example, there is a path C and D. Then the thing is that the time taken, okay, the path described, okay, the path described, or you can also say in terms of time also. but I would rather say in terms of path over here. Okay, so the actual path described by a ray of light in moving from one point to another by way of a number of reflections or refractions. Over here there might be a lot of refractions also, right? See, over here there might be a lot of refractions also. Suppose this, at this point there might be refraction, okay, at this point there might be, at this point there might be, and this refraction bend this light. That's why the light is not moving in a straight line. Why the light is not moving in a straight line? Because the refractions are bending the light. Okay, so the distance traveled by the light in going from A to B via any path. Okay, suppose this is C path and this is your D path. So the distance traveled by the light, okay, is such that it always will correspond to the one for which the time is an extremum. Okay, so suppose there is one more path. I take suppose one more path like this. Okay, then what happens is that when I take this path like this over here, suppose this is your point E. Okay, then this AEB path. Okay, ACB. So your ACB path will either be always maximum. Okay, the distance ACB will be always maximum as compared to your ADB or AEB, or either it will be minimum as compared to ADB or AEB, or it will be equal to both of them. Okay, you got it? See, there are three possible paths in light going from A to B. In the process of light going from A to B, there are three possible paths. One path is via C, one path is via E, one path is via D. The path which corresponds to ACB, okay, it is the distance, okay, actual ray path, okay, actual ray path. ACB is your actual ray path, and AEB and ADB are your imaginary ray paths. Okay, so the thing is that your ACB will either be always greater than AEB and ADB. Means this situation might arise. Either this situation is true, ACB greater than, okay, ACB greater than ADB, comma AEB. Either this situation might be there, either it will be less than both. Okay, means minimum ADB, AEB, or it will be equal to both. Okay, or it will be equal to both. In intermediate situation will not arise. Okay, intermediate situations mean a situation of this kind will not be there. Means ADB smaller than ACB and then AEB is the last. Such a situation will not arise. Got it? ADB is smaller than ACB is smaller than AEB. Such a situation will not arise because it is always an extremum. So this ACB will either be maximum or it will be minimum, or it will be equal to them. Okay, it will be either equal or maximum or minimum. Intermediate situation cannot arise that ACB is greater than ADB but smaller than AEB. Such a situation cannot arise. Or AEB is greater than ACB but ACB is smaller is greater than ADB. Okay, such a situation cannot arise. Means AEB and ADB cannot be maximum or minimum. Okay, if they are maximum, then they will be equal to ACB only. Okay, if in case they are not maximum or minimum, then they will be equal to ACB, but not anything other than that. Okay, so hopefully you got this. So this is what is your Fermat's principle. Now we will discuss the Fermat's principle, that we will discuss its derivation. Okay, we will do its derivation in the next class. Now how its derivation is done, we will see it. Okay, we will prove it. We will prove the theorem. Okay, we will prove the theorem, and we will look at the various perspectives So you got the meaning of the Fermat's theorem. Okay, so thank you very much. Just a second, I will have to switch off the record.